at P is f prime of x. Awesome. Great job. That's it. So the slope here is f prime of x. For this value, of course. If this is 5, it's f prime of 5. If this is 10, it's f prime of 10. Good. So now forget about that and look at this right triangle. Or if you want, look at these 2 points, if you want to say that. And tell me the slope of this line in this triangle. Having 2 points. How do we determine, if you want, how do we determine the slope of a line passing through 2 points?
Y minus 1, x minus 1.
Y minus 1, x minus 1. I'm not sure.
So you said between the slope between 2 points. Let's do
Yes.
the difference from the 2 points.
Yes. So how do I determine that? Rise.
The rise over run.
Rise over run. Very good. So this is also rise over run. I don't know what the rise is. This is the rise. But I know the run. What is the run?
X plus dx.
The run.
Oh, it's just dx.
That's it. So I don't know what the rise is, but the run is dx. And now look at this and say, of course I know what the rise is. And I will put it in.
Would it be the dy?
Of course, it cannot be anything else. Thank you very much. So this piece, the rise, this piece is dy. And now, I never told you that dy has a meaning, but it does. I never told you that dx has a meaning by itself, but it does. But it also dy. Okay, what does this represent? So dy is the differential of y or the function. What does that mean? It involves the derivatives. The derivative. The f prime. So, from this equation, can anyone give us the formula for dy? Will anyone like to solve for dy for us?
Was f prime times dx.
That's it. So please remember, there are 2 different concepts here, and I haven't finished. 2 concepts: differential of f of x, derivative of f of x. There are 2 different things. This one is just f prime. This one is dy equals f prime of x times dx. Not to be confused. When we're asked to find the derivative, we find this. When we're asked to find the differential, we have to find f prime and multiply by dx. One last concept before we look at problems. I want to come back. Let me know if you need more time.
Can you go up a little bit?
Yes.
Thank you. Just repeating.
Yes.
So you said the differential is the derivative times
Yes.
dx.
Yes, because we cross multiplied. Dy times 1 equals f prime times dx. Yes. So now I want to come back to the graph. And I want you to give me, that's the last thing here. I wanted to give me a relationship between delta y and dy. But not before we look at the graph. Don't say anything just yet. So, this is the exact change. Oh, so dy is the approximate change using the derivative. I want to write that down first before you answer. So the meaning of dy. So we know that delta y is the exact change triggered by dx or delta x. dy is the approximate change in f of x using the derivative. See, it uses the derivative to create the approximation. Okay, so this is not the exact change. This is the approximate using the derivative. Okay, so now let's go back to the graph. So this is the exact, this is the approximate. Can you give me a relationship between delta y and dy? Don't say anything before I re-emphasize. Q is here, not here. I'm zooming in so I can explain all this. Q is very close to P. So can anyone give us a relationship between the exact change and the approximated change? What should I put here? I need something in here.
Equals.
I can never say that, right? Because I can never say they're equal because this is the exact and this is the approximate. They can never be equal. I shouldn't say never, it could happen, but they are approximately the same. Okay, now I'm going to copy the definition of this, and I'm going to copy the definition of this and show you a little trick, and then we look at an example. So one more time, the exact change in the area, if you want, that example that I gave you, is approximately it's close to the approximation. This is f of x plus dx minus f of x, and this is f prime of x dx. So I'm going to move f of x to the other side, and we're going to get a very important result. F of x plus dx is approximately f of x plus f prime of x dx. And here's an example. I know I'm down to 5 minutes, so let me, that's not it. Where am I? That's not it. I lost my book. Did I lose my book? I lost my book. Okay. I lost my book? No, I didn't lose my book. I did lose my book. No, I didn't. Okay. I found my book. Okay. I would like us to differential. I did not talk about the linear approximation yet. So we're going to use differentials to estimate the given number. So please choose any number you want from here to estimate it.
32.
This one? You said 32?
Yes.
Perfect. 32. Let me copy it, 1 over 4.002. Excellent. Let me stop sharing. Good. So this is what we are asked to find. I'm asked to find this. This is my f of x plus dx. But I have to identify what x is. I have to identify f of x. And I have to identify dx. Once I identify x, f of x and dx, then I'm going to write this, and I'm done. And of course I have to find f prime of x after that. So by looking at this example, can anyone come up with the idea of, or an idea of what f of x might be?
Sorry, does that say 1 over 4,002?
F of x. We're talking about f of x.
Like the question.
We're talking about f of x. What could f of x be?
No, I think his question was that a 4 or a delta sign?
Yeah.
It's a 4. 4.002.
Oh.
Okay, thank you.
Did I copy something wrong?
No, I couldn't tell the difference either. We're good.
It looks like a delta or a triangle. The
Right.
4 does.
Oh,
There it is.
I'm sorry. My handwriting. I'm sorry.
No problem.
Perfect. So, can anyone give us an idea of what f of x could be?
Is it 1 over x?
Thank you. Good. Now let's look. What do you think x is?
Wait, I'm sorry. For the f of x, where do we get the 1 over x from?
So this is a number. If you cover that number, what kind of function you see? Do you see natural log? Do you
No.
see tangent?
No.
Do you see the square root?
No.
Do you see the absolute value?
No.
No. So just cover the number. What function do we see?
It's 1 over.
That's it. There is no
Okay.
other function here. We agree on that?
Yeah.
Perfect. So now we have to identify x. Now I'm looking at the number. I'm done with the function. I know what the function is. But what do you think x is?
4.02.
Careful.
4.
4.
4.0. Just 4.
4. What do you think the error is?
Put 0.002.
Perfect. What is f prime? We know it's negative 1 over x squared. We have everything we need. So then, approximately, since I wrote stuff here, I'm going to continue it here. F of x. Can anyone tell us what is f of x? We identified x, we identified f of x. So I want f of 4, right? So it's 1 over 4 minus. So this is it. This is the function, and this is x. X is 4. The function we established is 1 over x. So this is 1 over 4. Now, I have f prime of 4. So I have negative 1 over 16 times dx, which is 0.002. I'm done, but I have to clean it up. This is it. So I'm estimating something like this using the function itself of that number and the differential of y. This is dy. And this will be an approximation. This is not the equal symbol. Okay, so then let's see what we have. The least common denominator is definitely 16, but I can simplify it a little bit. So the least common denominator is 8. This needs to be multiplied by 2. So 2 minus 0.001, which is 1.999 over 8. Yes, we don't like to have decimal numbers in an answer, so I'm going to multiply top and bottom by 1,000. So 199 divided by 8,000. So I'm going to share, and I'm going to stop right after this. I just want to show 1 divided by 4.002, and I want to show 1999 divided by 8,000. Done with calculus.